Guys, today's topic is fault detection. I want you to pay attention. We'll be explaining what fault detection is. Another name for fault detection is troubleshooting, so we'll be explaining it, and we'll also identify and select some tools that we can use to detect fault. What is fault detection? This is an act of discovering why an equipment does not work properly and making suggestion on how it can be improved or fixed. So it is just simple. It is discovering. Actually, you are discovering, you are tending to search why an equipment is not working. If you have a radio set now and the radio set is not working, you trying to dismantle the radio set and trying to check, it's called fault detection. Or let's say an appliance is not working in your house, an electronic appliance is not working in your house, and you are trying to just check one or two things like that. That act actually is an act. That's why it is ACT. It is an act of discovering. So that act is called fault detection. So the first measure is to troubleshoot. That is to look for the fault. So by the time you are done looking for the fault, you will be able to know where the fault is, and you'll be able to know how to fix it. This is important because in some cases an equipment might be reported faulty, whereas such equipment problem can be caused by improper operation. In some other cases, an equipment problem might be reported on inaccurate information. So sometimes you need to check out the fault yourself. You need to check, okay, why is this thing not working? Oh, it's from this place. Okay, now I can now call someone that will repair this equipment for me. So it's just as simple as that. Actually, it's no big deal. So we'll be looking at the tools for fault detection. Majority of faults in different equipment are detected by using three standard tools, and these are the multi-stage methods, number two oscilloscope, and number three the signal generator. So we'll be taking these three what do they call it? We'll be taking these three standard tools. They are tools actually. So tools for fault detection. Number one is what? The multi-stage method. Number two, the multi-stage method. Now that one is not trying to tell us that, okay, what that place is just trying to tell us is that under the multi-stage methods, there are tools under the multi-stage method. Are you getting it? So it's not as if the multi-stage method is not also classified as a tool. It's a tool, but it's just that it is a general name for all those tools actually. The oscilloscope, and the third one is the signal generator. So let's look at the multi-stage method. It says this involves the use of either digital or analog tools to check and test the amount of electric current, voltage, resistance in an equipment. This method helps quick fault detection. Some examples of digital and analog tools are ohmmeter, voltmeter, ammeter, and multimeter. Okay, what the multi-stage method is just trying to tell us that it involves the use of digital or analog tools to check. There are sometimes when you have to call all these electricians and all these all these radio repairers, TV repairers. What do they call them again? They call them technicians actually. When they come to your house, you see that they are always coming with some set of tools that are different from hammer, chisel, and all those things. So they're always coming with some electronics kind of tools, which might be digital or analog. Like your tester now, your tester tool should be one of the tools used actually, because sometimes you just want to test if something is coming through. You understand? You want to know if light is actually coming through. If light is not coming through, that thing is not showing red, that means nothing is coming through. So from there you might know that, okay, you know where to channel your efforts to. Do you get? So that's what we are talking about here. So under the multi-stage method, we have tools that we use under the multi-stage method. Tools like the ohmmeter, the voltmeter, the ammeter, and the multimeter. And we know what the ohmmeter is used for, which we'll be talking about. I think we should have an idea what the voltmeter is used for from our GSS1, the ammeter, and the multimeter thereabout. So we'll be looking at the ohmmeter. The ohmmeter is an electrical instrument used to measure electrical resistance. It can be analog or digital. Actually, this one that you are looking at here is the digital one. looking at here is the digital one because I used it when I was in school. So what do you use it to do? You use it to check, to measure the electrical resistance. So when you are using it, this two knob, actually you put it, you might actually put it on one end of the wire and this other one on one end of the wire, like that. You can take the reading. There's a knob, actually. I don't know if this picture, okay, it's not, it's just showing the back view. There's a knob, actually. You switch it to the knob, and like that you can check the electrical resistance. When we're talking about electrical resistance, we're talking about when electric current wants to move, the amount of resistance. When we say something is resisting, that is hindering it from moving. So we want to know the amount of resistance in that circuit or in that electronic equipment. So another one is the voltmeter, and the voltmeter, we know already, a voltmeter is used to measure voltage. So we want to check the voltage. If the voltage is not giving us what it's meant to give us, then we know that there's an issue, so we have to fix it. So we use the voltmeter. This is an electrical instrument used for measuring potential difference. Potential difference is also the same thing, is also known as what? Voltage. Potential difference is also known as voltage. So don't let that confuse you. It can either be analog or what? Digital. Do you get? So another one is the ammeter. The ammeter, we know already, the ammeter is used to measure what? Current. So this is an electrical instrument used for measuring electric current. Can either be analog or what? Digital. So for this one, we tend to measure the amount of current that is in that electronic or electrical equipment. So we use all these equipment, actually, all these tools, to test. And the fourth one under the multi-stage method is called the multimeter, from the word multi. So you should know that it is actually doing more than one work. It's actually performing more than one operation. This is an electronic instrument that combines many measuring functions in one unit. It can either be analog or digital. At least you can see it. When they are saying it combines, that is, sometimes this multimeter, you can use this multimeter to do the work of an ohm meter. You can use the multimeter to do the work of a voltmeter. You can use the multimeter to do the work of an ammeter. It can measure current, it can measure resistance, it can measure frequency, many things, actually. That's why it's called a multi, from the word multi or multi, any way you want to pronounce it. Okay, so under the we said tools for fault detection, and we have discussed the one under multi-stage methods. We've discussed the tools under multi-stage methods. So now the next one we are going to is it's called the oscilloscope. The oscilloscope, is here, the oscilloscope. So we are coming to the oscilloscope here now. And what is an oscilloscope? This is used mainly to measure both direct current and alternating current. It is used to measure both direct current and alternating current. Now, when we say direct current, current that flows, just look at the cursor. Current that flow in what? One direction. It's just going like that. It's just moving like this. Follow the cursor now. Bah. It's moving like that. But when we talk about alternating current is like wave. They move like this. You can follow the cursor, or you can see the way the cursor is doing. So that's an example of alternating current. Actually, I think I should be able to draw. Okay, see alternating current. You can see, while your DC current, okay, just do like this. Okay, that's to show alternating. While your DC current is like this, just see. The DC current is a current that is on a straight line. So we use the oscilloscope actually to measure what? To measure current. Are you getting it? So it's used to measure current in waveform. So when we say waveform, actually you can see and that like that. And the alternating current is like the kind of current entering our house. Our NEPA light is an alternating current, but the current actually from a battery, maybe from a battery, is called a DC. The current from a battery is called a DC. Like all these your Tiger battery now, they are DC actually, but like NEPA lights now, power source generator, they are all AC actually. So to an extent, AC current actually can be measured using an oscilloscope, or can be tested using an oscilloscope, and also a direct current. Are we there? All right, so we move on to, you can see the oscilloscope. Actually, it has many channels, many channels, and this oscilloscope can also be used to measure frequency. So it Now we move to the next one. The next one is called the signal generator. So this signal generator now is like this. I'm coming, just check, just wait. So this signal generator, they are used to maintain different types of equipment when injecting suitable text signals into such equipment. Come again. These are used to maintain different types of equipment. They are used in maintaining. They use them to maintain different types of equipment when injecting suitable text signal into such equipment. So when we move, I want to explain something. Actually, the signal generator is just like this. It has many channels. It has many knobs. You can actually see them the way I am doing it like this. And if you okay, that's the end of the topic. Okay, but for this signal generator now, apart from maintaining different types of equipment when injecting suitable text signals, this one you put signals to it. Signal in form of pulse. Let me draw a pulse for you. The pulse is like this. You just see. Are you seeing? So that's the way it comes out in the signal generator. So they are used to maintain different type of equipment when injecting suitable text signals. So these are signals. These things are actually that have drawn here. Actually, they are signals. Actually, so when you input those signals into the signal generator, actually, it helps you to maintain. It helps you to maintain different types of equipment. So concerning fault detection, that is actually the end. So a recap: fault detection, sorry, is an art of discovering why an equipment does not work properly and making suggestions on how it can be improved. Actually, you must make suggestions. If you have not, if you are just checking and at the end of the day you are not making suggestion, it's not fault detection. So you must discover it and you must make suggestion. That is what will make it fault detection. And we have types of fault detection. We have three standard tools. We have the multi-stage methods, the oscilloscope, and the signal generator. While under the multi-stage methods, we have four types of tools there: the ohmmeter, the voltmeter, the ammeter, and the multimeter. And we've said all their functions. And this other tool, the oscilloscope, actually, and we've said what it is used for, and the signal generator. Have okay, let me give you an assignment. I'm coming. Right now, the assignment on fault detection. You submit your assignment this week, please. As you are watching this video, please just try to submit the assignment. There's a portion for assignment on your portal. And aside from that, you see the readable. On the readable, actually, you can always send your questions to the readable, and I'll answer back on the readable, or whenever the next video I'll be sending, I'll actually answer all questions sent, or I'll answer on readable. Make sure you keep checking the readables for your answers to the question, for your answers actually to the question asked. So if you actually come to the end of the class, you can copy your assignment like this, because you will not get it on your material this thing. So you can actually get your assignment like this. So I don't think there's anything for now. So have a wonderful year ahead. Bye.